Okay, so far we have learned about set notations, and now we are gonna move on to the next topic, which is important to set. Okay, the topic is about Venn diagram. I think we have done this before in probability topics back in chapter 3, I think. Not sure about that. Okay, so we are going to learn this again. Okay, a Venn diagram or Venn Euler diagram is a visual representation to show the relationship between sets. Okay, visual representation to show the relationship between sets. Okay, when we draw a Venn diagram, the circles inside represent each set. Okay, and we will Venn diagram contains circles, right? And inside of the circle we list out the set members. Okay, and outside of the Venn diagram, okay, let me show you. Outside of the Venn diagram, we should usually draw a rectangular box right here, rectangle. Okay, to represent the universal set, we use U to represent the universal set, which is the set of all elements that we consider in our set. Okay, the whole thing. And inside of the universal set, inside of the box, we draw circles to represent each set. For example, if we consider set A and set B, something like that, then we draw a circle to represent each one of them, and then we list out elements of A and B inside of the box. Okay. Again, in Venn diagram, the universal set with rectangle right here, we draw the universal set with rectangle, and the set inside that being considered, we draw it as circles. Okay, inside of the rectangle, and we write the elements of the universal set inside of the rectangle. For example, this is the box of the universal set, which is the set that contains all of the members that being considered, and here is the set A and set B, or it could be circles, two circles that are overlapped to each other. We have the common region here, or it could be a subset, which means it lies inside, like A is inside of B means A is a subset of B, something like that. For example, in example 6, given that U, okay, U is the universal set, means the set that contains all of the members that being considered in here, we consider set A, B, and C. So universal sets must contains all of the numbers here in all the sets. Okay. Now to sketch the Venn diagram, to represent this, first we draw rectangle to represent U. Okay. Oh, I don't want color. How do I get the color out? Oh, okay. And inside of the universal set, okay, we have U here, which means we consider inside of the box, not outside. So all of the numbers here must be inside of the box. And A is the set of 1, 2, 3. B is a set of 1, 2, 3, 4, 5. C is a set containing 3, 5, and 6, 7. So if we consider quickly, we can see that we have 3 as a common member of the 3 sets. So actually there is an overlapping region. So if we draw A, and another circle to represent B, and the third circle represents C. So we write like this: set A, set B, this circle for set C. And we list all the elements inside here. So 3 is in the middle of overlapping region, right? And A and B has 1, 2, 3 in common. So 1 and 2 must be here, or the overlapping region of A and B. So there's nothing in A only, okay? In B and C, we have 3 and 5. So 5 must be here as the overlapping region between B and C. And A and C has only 3 in common. So we don't have anything in overlapping region. Let's go back and look at A. A has elements 1, 2, 3. So everything is listed here. B containing 1, 2, 3, 4, 5. So 1, 2, 3 missing 4. So 4 is here. And C contains 3, 5, 6, and 7. So 3, 5, 6, 7 must be here in C only, because it's not in A. Now we are done with listing out the elements of A, B, and C. Now we need to look at the universal set, because this contains all of the numbers. So we can see that we still have, okay, 1, 2, 3, 4, 5, 6, 7. We still have 8, 9, 10 that are not in A, B, and C. So actually 8, 9, and 10 are out here, okay, in U, but not in A, B, or C. Okay. So this is an example of how to sketch a Venn diagram to represent the sets, okay, with members. All right. We can see more in the example after this. Okay, with the set operations. So this is the last topic that we need to learn in this class, which is the set operations. Okay, we need the set operations to combine many sets together and create a new set. Okay, and there are 4 common methods to achieve this, to combine the sets. The first method is the first operation is union. Okay, the union of A and B is we write A and it's like U, but it's a big U. A union B, we write like this. Okay, it's the set contains elements of set A or set B. So either the elements in A or the elements in B. So basically we list all the elements in A and all the elements in B. Okay, denoted by A union B. So A union B, if you write as a set builder notation, this is a set of X such that X is in A, or we combine with OR. Okay, this is OR. Union. A, X in A or X in B. Okay. So if we write down this, let me write down a box. A union B. If this is U and we have A, we have B. So A union B are all the elements in A or in B. So we shade everything here. Okay, we take everything in A, take everything in B. Okay, for example, if we have A as 1, 2, 3, 4, and B as 3, 4, 7. So A union B is going to be all the elements from A and from B. So 1, 2, 3, 4, and 7. We list everything out. Okay, 1, 2, 3, 4. 3, 4 already there. So still have 7 left. So put here. So we list everything in A and list everything in B. This is A union B. Next, the next operation is the intersection. So the intersection we represent as this. A is the upside with the upside down U. A intersects B. Okay. This set contains the elements of both A and B, which means we take the elements in common of A and B. Okay. So A intersect B is a set of X such that X is in A and we combine with and X in B. Alright, so if we draw a Venn diagram, it's the overlapping region. A, B here, so the intersection is the overlapping region. So if A and B are given in this example, so that we can see that we have 3 and 4 in common. So the intersection is going to be 3 and 4. Okay, so we take the elements in common. Alright, only the one in common, but for union we take everything. Okay, next, the complement. The complement of set A, so we write A prime, A dash, A prime, or A with the bar. Okay, A bar or A dash, A prime. The complement of the set is the set that contains all the members of the universal set. So it contains all of the elements in U but not in A. Okay, all members of U that are not members of A. So A complement is a set of X such that X is not in A. We take everything outside A. Okay, if we sketch the Venn diagram, and this is A, U, so A complement is the thing outside A. Or if you have A union B, like this, A and B, U, so A complement is still the thing outside A. It's gonna have elements in B too, but have to not cannot be in A. So for example, if U is set of 1, 3, 5, 9, 11, and your A is 5 and 11, so A complement must contains the elements in U but not in A. So A has 5, 11, so what is left is 1, 3, and 9. So A complement contains 1, 3, and 9. Now the last operation is the difference. Okay, this is complement, we use this. Okay, and the last operation is the difference, or A minus B. So the difference of set A and set B, or A minus B, is the set that contains element in set A but not in set B. So must be element in A but not in B. Okay, this is A minus B. If you draw a Venn diagram, this is A, this is B, This is U. So A minus B is the set that contains the elements in A but not in B. So A only, okay, not B. And cannot be outside here because it must be in A, okay, in A only, but cannot be in B because we subtract B out. Let's see, suppose A contains 1, 2, 3, 4, and 5, and B contains 2, 5, 9, 10. Then A minus B is gonna be the elements in A but not in B. So 2, 5 are in B. Then A minus B has only 1, 3, and 4. Okay, cannot contain elements in B. Or B minus A, you have to look in B and look for the elements which are not in A. So we have 2 and 5 in A, you have only 9, 10 left. So B minus A is 9, 10. That's it. Okay, these are 4 operations of set. We have a note here saying that if A and B have nothing in common, if they are not overlapping, then we call the set as disjoint sets. Okay, disjoint sets means they have nothing in common. The intersection is 0. Or empty set, the intersection has 0 element. Or okay, after you do the operation, the resulting is still a set, right? Because we do set operations, so the resulting, the result, it's gonna be set. A and B have nothing in common. Okay, right here we call this disjoint set. So, which means A and B, the intersection is empty, or the element in the intersection is 0. Oh, we do have the diagram here as well, which is the same as what I sketched before. You can take a look if you want a clear diagram. Okay, I'm gonna skip the application because we don't have time to do. So this one is not gonna be in the exam, okay, but you can read on your own. Okay, I put it like this in case you want to read it, not on the Alright, so let's say example 1. Okay, we need to find, given U, the universal set like this, A and B, find A union B, A intersect B, A complement, and A minus B. Okay, A union B, we take everything in A and we take everything in B. So list all of the elements out. 0, 1, 2, 3, 4, 5, and then we have 6, 7 from B. 0, 1, 2, 3, 4, 5 from A, and already have 0, 2, 3. So from B, I still have 6 and 7 left. So this is A union B. A intersects B. We take the elements in common. A and B have 0, 2, and 3 in common, right? Okay, so A intersects B is 0, 2, 3. Now A complement, element in A, element not in A but in U. In U but not in A. Okay, it has to be in U but not in A. let's see, 0, 1, 2, 3, 4, 5 are in A, so cannot take these elements. So what are left is 6, 7, 8. Okay, these are in U but not in A. And A minus B. A minus B will look for the elements in A but not in B. Okay, we know that we have this in common, so we have to look for the element outside of this. So 0 are in B, 2 are in B, 3 are in B, so cannot take this. Have only 1, 4, and 5 left, right? It has to be in A but not B. Okay, same thing here. B minus A, look for the elements in B but not in A. So 0, 2, 3 are in A, so I have 6 and 7 left. That's it. This is an example. Let's see. Example 2, shade the following sets. Okay, we need to shade the following sets. I need another page. Okay, I need to add page. Oops. The first one, we need to shade A intersect B complement. 5.1, no, 2.1, not 5. We need to shade this. Okay, first we combine. Okay, do one by one. We have A and B. Suppose we have A here, B here, overlapping region, and I need to draw two of this. So this is A, this is B complement, and the resulting diagram here. We draw A intersect B complement. Okay, so first we draw, we sketch right here, just A is here, and B complement, we take anything outside B, we shade everything outside B, and now we need to combine the shaded region here, finding the overlapping region. So look at this, they have, because we are looking at the intersection, so you need to look at the common region of these two, right? So which are the area is this, right? So A intersect B complement is just here. Okay, now 2.2, A minus B, union B minus A. Okay, I'm going to draw two pieces. Okay, A minus B and B minus A, and then we do the union. Let me copy this. Copy. Paste. Okay. Now, the first one I do A minus B, the second one I do B minus A, and then the last diagram I do the union. Okay, A minus B is here, right? And B minus A is here. And we take the union, mean we take all this possible region, shaded region. So the union, we take everything here and here. So this is A minus B union B minus A. Okay. 2.3. We have 3 sets, right? A complement intersect B. Oh, I erase this. Let me do easy one, union C then, otherwise it is too long. Okay, let me do this. So now we are working with 3 sets, right? 3 sets, A, B, and C. So A, B, and C. We need to shade this set. Copy it, paste. Okay, I need to do A complement and A complement intersect B, and then we do union. It's easy, we shade everything. So A complement, we shade everything outside A. Okay, outside A. Okay, then A complement intersects B, so we take the common region of this guy and B. So only this part, right? We shade only this part because it's the overlapping region of A complement and B. Now we take the union, we do this and we do C. The union, we take everything, is easy, so you just need to shade this part first. Okay, this is A complement intersect B, and then you shade more, add on C. Okay, you add C on. So you take everything here. All right, 2.4, last one. A intersects B and intersects A union C. This is the last example. Let's see. We draw this 3 boxes, and this is the result. And this is A intersects B, A union C, and the intersection of the two. Alright, so A intersects B is this guy, and A union C, so we take everything from A and take everything from C, and we consider the intersection of the two, so the overlapping region of these 2 pieces are going to be in the middle. Okay, that's it. This is the way to shade it. So I think if you have any question, you can ask me, and I have assignments for you, online assignment for you to do, and you can try, you can practice on that. Okay, I'm going to skip example 3, 4, and we have practice problem on application, so cannot do this, cannot do this. but you can do part 4. Okay, all right. I'm going to finish the topics and hope everyone can follow up and send me question if you have so, and have a good luck on the final exam.